Welcome everybody coming in. This is the first session of the afternoon track, and we're going to talk about AI infrastructure. As AI workloads scale, the boundaries of traditional infrastructure are being pushed. At the same time, we need to ensure the robustness, the operational integrity and performance of this infrastructure in order to be able to scale the AI ecosystem that we're seeing growing today. And so the session today will focus on the collaboration between NVIDIA and Cisco in order to build purpose-built solutions for enterprise AI systems. Your speakers today will be Will Etherton and Kevin Wallenweber. Will Etherton, he leads the Cisco team in charge of data center, web, and service providers solutions. And Kevin Wallenweber is the Senior Vice President and General Manager of Cisco's Data Center and Provider Connectivity Organization. Please join me in welcoming them to talk about the building the future of AI infrastructure.
Thank you very much. And I don't know if any of you had to run over from the keynote, but it was quite a haul in a very fast time. So very happy to be here today. And just wanted to reflect that a year ago, was very happy to come and join into an NVIDIA talk before it was as cool to be at NVIDIA GTC for Vendors as it is this year. In the past year, from a Cisco standpoint, there's been a lot of delivery in the AI infrastructure area. So GPU optimized servers, 800 gig networking, 50T switches, coherent optics for data center interconnect, and also starting to get into solution level, so AI pods and aspects of how security can integrate in, and so AI defense and hybrid mesh firewall. So from a Cisco and NVIDIA standpoint, a year ago, we announced that Cisco and NVIDIA were going to start working together. And over the last year, there's been engineering projects that we've engaged with, in particular around our Hyperfabric and our Hyperfabric AI, which is a project to do a cloud management relative to a cluster, cloud level management for a cluster. And the announcement we made 2 or 3 weeks ago was expanding that much broader across enterprise reference architecture, across congestion management between NVIDIA and Cisco. And then also today, we're going to talk a little bit about expanding that with the Cisco Secure AI Factory. So rather than having me from Cisco really drown on about the partnership, I'm very happy to have Gilad join us. And Gilad is the SVP for networking at NVIDIA. And I believe it was late last year that Gilad and I were at a meal, and we were discussing how could we do more between us for the benefit of our customers. And so with that, I'm going to ask Gilad to say a few words, and I'll think on how he views what we're doing together. So thanks.
Yeah, thank you, Will.
Okay.
It's on? Oh, okay, it's on. By the way, the previous slide, who's the guy there? It's not you, right? We were debating.
I wore a jacket last year. No more jackets. Yes.
Okay. So we have an hour, right? I can talk hour about this slide.
We knew you would hit most of our time.
Yeah, exactly. No, it's a packed room, by the way, so it's great. There is a couple of seats here, by the way, if people are standing there in the back, if you want, there is a couple of seats in the front. Will does not speak and Kevin does not speak, so you're safe. Few things on the partnership. So first, Cisco is, well, let's start from that. We talk networking, but in my perspective, networking is not more networking. Okay, networking kind of refers to a switch, a NIC. Networking has become a full compute infrastructure. Okay, that's from the infrastructure, and it's not a single device. It's a full platform. It includes components for switching and cables and NICs, and there is a huge amount of software that runs on top of that. But at the end, it needs to work as one entity. Okay, that actually forms the scale or the compute infrastructure. And that infrastructure determines if a data center is a server farm or a data center is an AI factory. So that's why it's important to actually make sure that the right infrastructure is in its place. Cisco is a leading infrastructure provider for enterprise. And it was just clear from our perspective that we want to partner with Cisco to enable drive AI into the enterprise and work together with the Cisco force and Cisco capabilities and the Cisco software and everything that developed in order to bring AI to the enterprise. So we wanted to do that for a long time. Now, for AI, NVIDIA has built a compute infrastructure called Spectrum-X. And Spectrum-X has a lot of components inside, but it was optimized for AI, if it's training or inferencing. And partner with Cisco, essentially enable us to bring the Spectrum-X elements into the Cisco infrastructure. It can work with different combinations inside, so there is a Spectrum-X infrastructure that will leverage the Cisco ASICs. Cisco will also bring our ASICs, so they're going to be full combination, full flexibility, full optimization end-to-end from an AI infrastructure to support the different workloads of AI, and working together to make sure that AI can go easily into the enterprise, and enterprise customers can consume AI in a most effective way. So that's the goal of our partnership. There was an announcement. You're going to hear more as we move forward from the capabilities and the elements that will be provided. Thank you, Will.
Thank you.
It was great working with you, and there is a great future moving forward.
Great.
Thank you.
Thank you very much. Great. Much appreciate. Glad dropping by. I know his calendar is jam-packed today. So from that, we are going to go through just a few things, including getting to some benchmarking data. No surprise, Ethernet is going to be a key part of what we're going to be talking about here. Jensen mentioned in his keynote earlier that while InfiniBand has been great, that Ethernet really allows a wider deployment base for the broader industry. And some of the performance data I'll be going through is actually outcomes as we just went through and got the enterprise reference architecture approval with NVIDIA, and we just put out a press release for that includes Cisco Silicon One. And so I'll be going through some of that data, and then we're currently working on the NVIDIA cloud platform. And so, I just want to say on the Ethernet side, not only has it been the choice for decades, but currently with things like Sonic, which we're massive supporters of, that also brings a further layer of open ecosystem on top of Ethernet for AI. And we are very happy with the engagements we've had with hyperscaler, with the contributions we are making, and with some new architectural features that we're bringing to Sonic. So overall, Ethernet is the safe bet, is the message, of course. So as we go into, and we're big believers, and we've put together a benchmarking team at Cisco, led by Rakesh Kumar, who is here today. And that, as part of that, our intent starting today is that we're going to start putting out a lot more data. We believe that's important so that you can put the performance for different scale clusters and for different schemes in context. And so, start off, and again, I'm going to mostly focus on Cisco data, but a lot of this you can go and do comparisons elsewhere from an industry. So start off with a very simple one, all reduced, because it has a lot of many-to-many traffic, or all-to-one traffic. So in this context, it's 120 GPA, so this is 128 GPU. So this is in a smaller enterprise cluster starting, and this is some beginning data from a nickel benchmark. And if you go look at like semi-analysis and compare with InfiniBand with other Ethernet, you're going to see it's inline. It's all within 1% or 2% either way. And you're going to see, again, this kind of data we're going to be starting to publish in blogs and more common. So here is, again, using Cisco Silicon One, 120 GPU. In this case, we start off looking at different patterns, all reduce, broadcast. And start off very simple one, job completion time at 16 gigabyte messages, all about the same, whether you're using ECMP, which obviously everyone knows. Flowlet is a Cisco Silicon One congestion aware in the fabric, and then packet spray, of course, is packet spray with the assumption that you have reordering on the NIC side. And so, left side basically all good across them. The right side is where you start to see that after all to all, that as you go to all reduce and broadcast, that the fairness index for ECMP comes down, and either Flowlet or packet spray are doing pretty well. And I think with a very high, and I think one of the macro messages, and again, this is a small cluster area, as we do benchmarking higher, what we see is that, in the, I'll say, hundreds of GPUs, that using either, certainly you want to do something more in ECMP, but using either like Silicon One congestion with the flowlet or using packet spray, either one of those will get you into good performance. As you go into thousands and tens of thousands of GPUs, that's where, as you start to have things like failures, they're going to be much more common, more chaotic. That's where the combination of the two, we believe, is very beneficial. And so, going on, here is a case where we're using the IB perf tool, and then we're doing induced congestion. So 31 to 1 GPU. And again, we're comparing all on Cisco Silicon One in the same cluster, the same general. We're comparing ECMP, flowlet, packet spray. Here you can see that the job completion time under this is certainly better for flowlet and packet spray, both very similar to each other. Where you do start to see, and again, while the job completion times are similar, where you do start to see an indication of the benefits of having packet spray in the overall architecture is on the right side, where you can see that certainly the buffer occupancy is much smaller on the packet spray side. And so, again, I think this is, we're at a fun time from an industry. There are competitors out there that are really working to say, hey, you can do 100% everything in the fabric, and you don't need to really, work with other partners across. Our message is that at hundreds of GPUs, that it is very reasonable to use either fabric congestion or packets. As we get into thousands or 10,000, that it really is this is where it's important to really bring together technologies and use super NIC packet spray type of thing, and flowlet together can be a good combo. And that really, if I come back to the partnership with NVIDIA, one of the key things around a 5+ year partnership, multi-generational, 100T, 200T, is that these kind of interrelation, whether it's the super NIC and the characteristics that to the fabric and congestion aware need to be more tightly incorporated over time. And we can each operate in a silo, or we can have situations like Cisco and NVIDIA working together to share that data so that it operates more seamless. And that, again, is either with Cisco Silicon One or with Spectrum. And so, from that standpoint, the last chart I had was ML Commons. And again, this one has some older models like Llama 2. But again, this is data that we'll be submitting to ML Commons shortly. And it, again, is very in line with what you're going to see from other comparable clusters and benchmarks. So overall, we're very happy with our first results. If you have really detailed questions, don't ask me, ask Rakesh. But we're very happy with this. And our intent is to be a cadence here moving forward that we'll be putting out a larger cluster size, more data. And again, this was with our G200 Cisco Silicon One, and that is both applicable to our Nexus as well as our hyperfabric modes of operation. And so with that, I think the last topic, and prepping to hand off to Kevin, is to talk about operations. So I think Jensen hit this a little bit this morning when he talked about some examples, but let's take one example. And again, this is an example of I would say a modest deployment from this iteration with customers. So this is 12 UCS servers. Very small, 96 total GPUs, a handful of switches. And where you get fun is, those numbers are reasonable. And in the conventional data center architectures, the operational side of this, everything from cabling onwards was understandable. Now we're talking about things like, in this config, 445 links on the back-end network, 980 total optics. And so this is where things start to get crazy. And if I broaden this from a operational standpoint, beyond the optics and the cabling standpoint, building a performant AI cluster not only has topics like the load balancing type algorithms that I was mentioning earlier, not only has things like the optics, but there is actually a whole bunch of factors that have to be considered to pull all these pieces together. Across validation of performance, is the system built correctly? So assurance of the construction of the system, the wiring of the system, does it match what the original design was? Lifecycle management, and you could go on and on. I think today this is a very at the high end, it's a very services heavy industry, which is fine. But as we go into broader enterprise and wanting to help companies do smaller deployments without maybe an army of services, that's where we start to think about what could we do different, what could we do better. And with that, I'm going to hand it to Kevin.
All right, so at Cisco, obviously, we've been building large data center fabrics for years, and we built a new system that we call Hyperfabric. We actually just launched it, just started shipping it, Dan, like a couple days ago, I think. It's live and in production. And this is really designed around simplifying how we want to go about build fabrics. It's a cloud-based management infrastructure. It takes care of a lot of the underlying problems that people have when building out large fabrics. And then that dinner that Will was talking about 15 months ago, we sat down with NVIDIA, and this problem, or this solution aligned really well to the problem we needed to solve with building out large clusters. Because if you listen to Gilad, the way he describes it exactly the way I describe it, which is we're using all the same components. We've got compute, we've got storage, we've got networking, we've got operational tool sets, but these things have to work together as a system. And so what we wanted to do was try to simplify how you operate things, but not just with the controller that operates the network. We wanted to bring it all the way back to the design of the system. And so one of the things with Hyperfabric AI is it's not just the management, control, and running of the system at the end state. It actually pulls us all the way back to the design as a system. And so your first interaction with this tool is actually to go in. You can do this today. You don't have to have equipment in your network. You don't have to build anything. You can go to hyperfabric.cisco.com and start building out a template for a design. And the extension that we drove to build that end-to-end system for AI was to look at not just the fabric, which is what Hyperfabric was started out to build, but look at compute, look at how we connect them together, look at basic reference architectures for certain types of clusters. And so we want to make it simple and easy for customers to actually go about, build a template, and start to think about what it would take to go and deploy an AI cluster at a size and complexity that eventually will scale up pretty significantly. From that, you do your design, and then we have to get into things like building a blueprint, an architectural blueprint of what that fabric's going to look like, and all the way down to things like the cable plan. That picture Will showed was perfect because, I've been in networking for almost 30 years. We always draw our little clouds and lines connected, but the complexity inside of that, especially for a large fabric like this, is pretty great. And so not only can you design, build a reference design, you take that one step down, you get an entire architectural blueprint, and this goes down even to the cabling, the optics. Those things, as you saw from Jensen this morning, those things actually matter. And how you build, the length of cables, if you're building something like a rail optimized design, a lot of the mistakes can happen. And let's say, if you've built out large fabrics before, I'm sure a lot of you guys in this room have, let's say you go and order a bunch of optics, you order the wrong optics for the wrong reaches or for the wrong cables, having to then go back and wait for the supply chain and wait for those to come in can slow things down by days or weeks or even months. So the thought process was build everything into a common ecosystem, allow us to build out that architectural blueprint and cabling plan, and then once you submit the design, we'll give you that complete bill of materials, complete architectural blueprint down to the exact PIDs, the exact optics, the exact cables that are going to be in that design. So once you have a design you want to go and build, then you move to the next phase, and you can actually generate a complete bill of materials from that architectural design. So from instantiation, just going into a website and clicking and building an architectural blueprint, to generating a full bill of materials. Obviously, we can spit out that bill of materials for you, and we're even connecting it to our commerce workspace to be able to through APIs, to be able to then even generate a quote or get an estimate for what that's going to cost with that specific bill of materials. So now you have everything that you need. Let's say you've placed the order. Obviously, there's a step in here of trucks and a lot of boxes and people coming in to deliver. But once that equipment comes, this is actually the next phase of complexity that we've seen with a lot of our customers. And like Will was pointing out, you can put all these machine parts together to build an engine, but understanding exactly how that engine needs to run and actually gets built up is also complex. And so we've built a helping hands application that's optimized for mobile phones, where you can take that plan, it'll give you a step-by-step view of how you want to interconnect everything, which optics go into which devices, which port from which switch goes to which switch, goes through and guides you through the entire thing, and it validates every single step. So going back to your experience, How many people have ever been in a room, you connect up a fabric, something's not working, and you're troubleshooting, you're looking back at craft tools, or you're calling people to go run tests. So here you can actually look and identify immediately if this port is incorrectly connected. The Helping Hands application will tell you, and you can connect it all up correctly. And then we validate everything from end to end. So we can validate the complete design. Once you've cabled it all up and you have it running, we understand that it's valid, it's ready to go, and you can move on to the next step. And the step that we did with the NVIDIA teams is this is how we build Hyperfabric. Hyperfabric AI actually extends that solution or that system out into the compute node itself. So we have our agents running on the Bluefield NICs. We're able to do really intelligent, not just design and validation, but even testing of the system moving forward. So I'll show you that in a second. And then this becomes the tool or the single UI for every single part of that cluster. So in a fabric today, you've got networks. You're connecting those switches together to build a network fabric. But because we're looking at this as an entire system, we go down into management of the NICs themselves as a networking entity. We can do things like look at the entire NVIDIA stack. So everything that you need to integrate and build out this fabric, build this design, and actually then run AI workloads, all of those cluster components are managed through this one UI. So you're not having to swivel chair through and move through different elements. We think it's going to make it a lot simpler for customers to actually deploy, manage, and run these types of networks. And then last, the really interesting thing, I think, is continuous monitoring. So as you think about running a big fabric, the one big difference with a network fabric like this is you're going to be running workloads, especially if you're doing training or fine-tuning workloads, you might be running for days or weeks at a time. And so it's not just that you need to build the fabric, run it once and set it up, and it's guaranteed good for the rest of its life. You need to look at the overall life cycle of this and how it's performing throughout the entire the time frame of a run or of a job. And so what we've built is hardware acceleration into the devices to where we can actually do a full connectivity map, look at end-to-end connectivity, latency, and very quickly identify problems. So anybody who's ever run large workloads before, one of the biggest challenges we have is it's not always a GPU that fails or an optic that fails or a fiber that fails or a switch that fails. It can be anything inside that system. And any downtime means GPUs aren't being run at high utilization. And so the spend that you put into that compute and those GPUs isn't getting leveraged. And so by doing this, we can get a very, very quick view of where there's potential hotspots or issues in the network and then remediate them quickly. So the goal is focus less time on how to build and how to manage and how to run the fabric and more time on actually running those AI workloads. And so with that, what we've done is we've pulled all of this stuff together into what we call our Cisco Secure AI Factory, leveraging the AI Factory architectures that NVIDIA has built. And so we have the enterprise reference architecture, which is up to 1,000 GPUs certified today. We're working on the NCP architecture, which is what will help us scale up or show value in those larger clusters. But remember, this is an entire system. And so we have the ability to deliver all of the different components in this stack. So we have our UCS, which is our compute platform. We have all of the NVIDIA GPUs and NICs and things necessary to build up the capabilities we need in a fabric. We partner with majority of the large storage vendors, and so we can bring storage into this ecosystem. Networking is something that we built our entire company on, and so obviously we have the networking components to bring this together. And that partnership with NVIDIA allows us to take our silicon and bring it into the Spectrum-X architecture, or leverage Spectrum silicon where in backend or other places where you want the performance or consistency that you have already been deploying with the NVIDIA silicon in other places. And so the big value is when you think about a network, you have the back-end network that connects GPUs, and you have the front-end network that connects the rest of your workloads and connects to your users. And as you think about the evolution of those, today you actually manage those with different tool sets. You might have one system that manages your back-end network, and then maybe you're using Cisco Nexus or some other technology to manage the front end. With this, we can actually unify the management of both of those and perform them in a much, much simpler way. And so cluster management is that Hyperfabric AI solution that I talked about, but we can also leverage Nexus Dashboard and all of our existing tools to manage those fabrics and those Nexus switches. And then on top of that, we bring all of the other components required for running the AI workloads, so things like NVAIE, all part of that managed stack. But with the Secure AI Factory, we're actually bringing a few new things, which Will's going to talk about.
So we just put out today. And we were happy to have Jensen endorse in the press release about the Cisco Secure AI Factory. And the key components were building on the infrastructure side of this, which we'd announced the partnership with NVIDIA, is also bringing in key technologies like AI Defense and Hypershield from Cisco. And the key way to think about that, I'll go top down. AI Defense is a new technology that Cisco has just launched and just started to market, which is helping provide observability protection around not only on-prem, but also web-based LLMs and technologies, as well as providing other ongoing protections and checks at that application LLM level. And then Hypershield at either a eBPF, a software switch, or the other thing that we announced is that we do have in development a notion that with Hypershield, which essentially is a next generation firewall technology, that we can leverage the Bluefield north-south NICs, again, in a management architecture that remains consistency around the entire perimeter of the cluster. And so, while a smart switch, which Cisco's recently announced, could be potentially leveraged for that, given that you have a consistent deployment of high-performance north-south NICs across your AI cluster, you can form policies in a symmetrical fashion and in a way that does not require a lot of additional hardware investment beyond what was already being spent. And so that is in development. And again, that's something that, even beyond that, there's some new capabilities that NVIDIA just announced on the Bluefield 3 around introspection and memory for protection. I think that was also announced today. And so we have been starting to iterate with them on how we would also incorporate that into the overall Secure AI Factory architecture. And so this, again, is a new launch to enhance on the AI Factory theme that NVIDIA has been out there with for the past year or such, and something that we're very excited about. And so,
yeah,
okay.
And that's one of the things we've heard directly from customers as we look at more adoption of AI workloads inside of large enterprises. Being able to simply and easily manage and also secure that infrastructure is something that we've heard a lot from customers. So the goal was to take the security side of our portfolio, marry it with networking, and then obviously partner with NVIDIA to bring those all together into simple, easy-to-use solutions. So the partnership itself, if it wasn't clear, is much more than just a point delivery of product. We've done some really interesting integrations where we take our silicon and we can integrate our Nexus switches into the Spectrum X architecture. We'll be doing an evolution of a Spectrum switch where we can take Spectrum switch and run Cisco network operating systems on top and fully manage it inside of the same ecosystem. And Will did a great job of describing this as a multi-generational partnership. So it's not just products today. We'll continue to do engineering evolution, whether it's just on the silicon side or if there's new things that we discover, congestion, traffic management, or any type of protocols that are running across those devices, we'll do joint development with NVIDIA there. We do feel like moving Ethernet into especially the enterprise AI workloads is going to be critical, and being able to operate and manage that in the same way that you manage your existing ecosystem is a powerful thing. It's going to simplify and make it easier for customers to deploy, and they're not going to have to manage these two networks independently. We're starting to see a lot more stuff happen with storage, and you might actually even have a third network. You have a front end, you have a back end, and you have a storage network, and the ability to manage.
And a management network.
Yeah, and a management
So we've
network.
actually seen, and the great thing is it's all Ethernet, but yeah, that starts getting a little crazy.
So trying to get as much consistency and simplification of how we operate and manage is what we're after here. Hyperfabric itself is shipping today. And then the Hyperfabric AI solution is going to come around summertime, where we'll extend that. That's where we have the agents running on the GPU-based compute, and we can build the end-to-end AI structure that I talked about before. And then AI Defense is a new technology that we launched in January. It's in public beta right now, and we expect to see that rolling out pretty significantly in the near future. We've got a lot of interest inbound from customers as they look to protect the AI workloads that they run, and even look at the security of the LLMs themselves. It's something worth looking at. So with that, I think we'll pause. I know we have a little bit of time for Q&A, but thank you very much and appreciate you joining. Any comments, questions? I think we have a mic we can pass around.
Or you can yell really loud.
Yeah.
And up here.
Hi, just a quick question. Excuse me. Just a quick question. What can you elaborate on? How do you bring Nexus or Silicon One into Spectrum X architecture? What does this exactly mean?
Yeah. Okay, so the question I think folks heard, so what does it mean for Cisco Silicon One to be in Spectrum X? The benchmarking and the reference architecture, for instance, on the enterprise reference, we just went through a process where, using the config that NVIDIA has as a template, we went through, we did all of the testing, we then sat down and reviewed with NVIDIA. So that's one part. At a technology standpoint, there's also in this generation, as in with Bluefield 3 Super NIC or ConnectX 7 moving to ConnectX 8, there is some interconnection as far as the Super NIC recognizing that the fabric is friendly. And so as part of our partnership, that's a software set of updates that we'll be making on top of both Nexus, and it will be in hyperfabric such that Cisco Silicon One switches can then operate in a mode that they are interpreted as friendly. And that has two levels. There's, I would sort of say, a base level, and then there's a level that actually gets into telemetry level. So those two levels, the first level, and again, these are things where they are additive, so that'll be in place in a very short time frame. The second level is going to take a little bit more development time, but we're working now. But the other part I like to come back to is, and this is why the multi-generational is so important, this is not standing still. This was, if you go back 18 months, the relationship, what was going to be the role of the NIC end to end, what was going to be the role of the fabric in that, how would that all interrelate, what would be the proportion, what sort of notification or messaging would be required. That's evolved in the last it's going to evolve in the next 2 years. And so as we went into this, the expectation, and I've been very happy with the engineering to engagement, is really about working on, what's this going to look like, at 100T, at 200T, what are the next set of changes that we need to have such that both sides can line up between the Super NIC and Cisco Silicon One. And then the other part of, the Spectrum X and so on is, for us, is also bringing that Spectrum Silicon into the Cisco family. And so, both hyperfabric and Nexus OS running. And that gives, customers optionality that if they want to have consistent operations, that they can then choose, for instance, Cisco Silicon One front end and Cisco Silicon back end, or Cisco Silicon front end and Spectrum on the back end, all with common operational model, a la either hyperfabric and XOS. So we think that, again, this gives customers more choice. It also provides two vendors and two silicon assembly lines, if you will, supporting customers in a common architecture. So that was a long answer, but that was the answer. So, okay, other questions?
There's one about halfway back. Jared's the runner.
Can you share more insights on agent sitting in the NIC cards? Is it more of a traffic visibility, or like a buffers, etc., or is it more like a security element?
I didn't hear the very first
more
part.
about what the agent does in the NIC.
Oh, the agent. Okay, so from an agent standpoint, on the compute host relative to both the front-end NICs, the north-south NICs, and the back-end NICs, as well as the host. There's actually quite a few functionalities that have been evolving as we've been in development on this. And again, the Hyperfabric AI with the compute side added in is a summertime deliverable, just as I'm an engineering manager, so I have to point that out. But multiple things. So on the compute side, there's a whole set around system-level performance metrics and operational health around that compute server. And then on a per GPU basis, there's information we can pull. For the NICs themselves, there's actually things related to generating synthetic traffic, any-to-any, being able to then take that, bring that up into the Hyperfabric control plane, and be able to then do plots and analysis across all GPUs to all GPUs. And again, when you start having things like 490-some links for a 12 server, you then extrapolate that out to 12 racks. And if you don't have that level of and again, folks have done very well. You're putting putting together software on a per deployment basis. But the goal here again is really out of the box, have this instrumented in one controller, and have that be something that you can use whether you're putting 2 boxes or 200 boxes down. So those are, but yeah, there's quite a range. So this is way more than like I'm going to query a couple registers on the NIC. So yeah. Any other questions? Okay.
One of the interesting parts of the keynote speech was the co-packaged optics announcement. What are Cisco's thoughts in that space, and does that announcement start coloring your future plans in that area?
Okay, so I will hit a little there. Yeah, so first of all, we have been a fan and supporter of the direction of co-packaged optics for a long time. We had was it 12 or 25T OFC? 25T OFC a demo set up in 23, and that's something we've had ongoing development interest in. I will say that, and I think the whole industry would applaud the speed that NVIDIA moves and the amount of money that they're marshaling to make this happen. And so we do think this is the right direction. I think there's certainly a question on at what scale, and in what is it something that will predominantly be only with liquid cooled and not as applicable. So I think there's questions that I'm sure NVIDIA has answers, but that we're just starting it with them. It is something that we absolutely will be going that direction over time, and we will look at, we have our own significant optics development at Cisco, both in client as well as in coherent with the Kesho acquisition. But so we do have extensive technology, but this is, we are also interested to partner with NVIDIA on what makes sense, and if there's something, without knowing, I'll just say if there's something there that can accelerate, we will absolutely work to partner with NVIDIA on that.
Yeah, and what I liked was the partner ecosystem part of it as well, because although the technologies have existed for a while, there's a lot of complexity. I saw Fabrinet and others on there. There's a lot of complexity in manufacturing and aligning. He talked about 1,000 fibers coming off one of those devices. We were doing things in little optics that were 10 by 10 gig connections, and just aligning those to the silicon photonics is difficult. So there's a lot of manufacturing challenges that need to get solved, and so I think the approach of both investing heavily in the technology but also building the ecosystem around it is exciting as well. So yeah, we heard about it with everybody else, so obviously we got to work through what that partnership looks like, but at the same time we've been down that path for a while.
Okay. Any other questions? Almost? Okay.
All right, well,
thank you very much.
Appreciate it. Thanks for making it back for the first session after the keynote, and have a good week.